Okay, so today we're going to be looking at the anatomy of a Java class, in particular the die class. We're going to open it up, and inside we're going to talk about 5 things: instance variables, constructors, different types of methods that we see, 2 methods in particular, the toString, the toString and equals method, and then we'll see that we have 2 new Javadoc tags. Okay, so on the left-hand side, you'll see here that I kind of have my whiteboard. On the right-hand side here, I have BlueJ, and I've pulled up the die class. We've seen this class a lot. Mostly, we've been focusing and looking at the documentation for this class. Today, we're really going to open it up and look inside. You can find the die class posted to the course webpage. Okay, so you can you might even want to maybe print out the die class and write your notes on that, or just write your notes, I guess, in your notebook. Okay. Okay, so we're really going to start from the top to the bottom in the die class. And the first thing that we see is kind of like usual. We have a Javadoc comment here. This class represents a single n-sided die. The top number is called the face value. You can roll the die, or you can explicitly set the die to a particular face value, and then my name and the date. There's nothing much different there. It's kind of what it's always been. Okay, so inside, the very first thing we see at the top is a set of 3 variables. These are called instance variables, or sometimes people call them fields. You'll notice that these 3 variables are not declared inside a method. Instead, they're just declared inside the class. And what that means is that their scope is the entire class. So any method in the class can access, change, update, and basically any method can use these variables. We have 3 variables here. So I have one, which is the number of sides of the die. I have a random object, which I called RNG, and then I have another integer, which represents the current face value for the die. You'll notice that there's a new keyword. Each of these variables I'm declaring as private. So we've seen private methods. We can also have private instance variables. The reason why is that we don't want someone from outside of the die class to be able to access these variables, because then they could change the face value to be whatever they want it to be, like -1,000,000. So by declaring these 3 variables private, it means that the only place where you can access or change these variables is from inside of the die class. Okay, so these are our 3 instance variables. Instance variables, their purpose is to store the current state of the object. And I talked about that in the last video. If we have a die object, its current state is really reflected in, how many sides does it have and what's the current face value. And as the face value changes, right, the value stored in this variable changes. And so these variables store, or they capture, the current state of the object. Okay, moving down, we have 2 methods here, and I'm going to highlight them. These are methods, but they're quite special methods. They are called constructors. And we've used constructors before. Every time we say die d equals new die, we are using or calling the constructor. And now for the first time, we get to kind of look inside the constructor and see what does it actually do. So the first thing is, what's the purpose of the constructor? And I'm showing that here in all caps. The purpose of your constructor is to initialize all of the instance variables. So I have 3 instance variables. Thus, I have 3 lines inside each of my constructors. Okay, this constructor here creates a 6-sided die, and it gives it initial face value of 1. I kind of created this constructor because I would say, yeah, I'm going to say almost always people want a 6-sided die. Like, that's the most common type of die. But I do have a second constructor down here. this constructor takes in an integer for the number of sides. And so you would use this constructor if you wanted a 10-sided or a 20-sided die or whatever. Looking inside, the code inside the constructor is giving an initial value to each instance variable. So it's setting number of sides to 6. It's setting RNG to a new random, and it's setting face value to 1. Okay, for now, let's ignore this keyword. Let's ignore this keyword, whatever. Just ignore this for now, and we'll come back to that in a bit. But basically, each line of code is just initializing one of our instance variables. Similarly, down here, whatever number the user passes in, I'm taking that number and I'm storing it in my instance variable. And then I, again, create a new random object, and then I store the number 1 into face value. So when someone creates an object of type die, they're going to call either this constructor or this constructor. So both constructors have to initialize all of the instance variables because only one constructor will be called. Either the person will say die d equals new die, and they'll call this constructor, or they will say die d equals new die, and they'll pass in a number, which is calling this constructor. So both constructors have to initialize all of the instance variables. Now, constructors have a very special method header. You'll notice there's no return type, not even void, and the name of the constructor has to match the name of the class. And those are 2 rules. There can be no return type, and the name of the constructor matches the name of the class. Also, you can have as many constructors as you want. They just have to differ in their formal parameters. Okay, so I have one constructor with no formal parameters and one constructor that has a single formal parameter that's an integer. I could not have another constructor that also takes a single integer because then there's no way to distinguish between them. I could, however, have another constructor that took 2 integers or an integer and a double or whatever. Okay, so you can have as many constructors as you want, but they have to differ in terms of their formal parameters. Lastly, let's talk about this keyword. The this keyword helps distinguish between local variables and instance variables. So you'll notice down here, I'm taking in a local variable called num sides. It's the number of sides of the die. Up here, I also have an instance variable that I called num sides. It stores the number of sides of the die. Okay, the question then is, inside this constructor, if I use the variable num sides, which variable am I referring to? Do you mean the input num sides, or do you mean the instance variable num sides? And it's not clear. There's kind of some ambiguity. Now, one way I could solve this problem is I could just call this input something different, like, I don't know, the num sides, whatever, just call it something different. And then I don't have that problem anymore. Now my instance variable and my local variable have 2 different names. And that's a totally wonderful, legitimate solution, and feel free to do that. However, you'll notice the more you code, it kind of becomes annoying to have to think of multiple names for the same value. And so this allows you to disambiguate. So what is this? This points to this object. Okay, so this is a keyword that holds the memory address for this particular object. So when I say this .num sides, I mean go to this object. The dot operator says go inside, and there should be a variable called num sides, and that is this variable here. So this .num sides is the unambiguous way of referring to the instance variable num sides. Okay. If you were to just say num sides, this is the local variable. This .num sides is the instance variable. Okay, so it just helps you disambiguate. You can think of this.numSize as like the full name, right? Like I have a name America, but in fact I have a full name, America Lene Chambers. In the same way, when you say this.numSize, you are unambiguously referring to the instance variables. So here I'm using this.numSize because I have two variables with the same name. Here I'm using this.rng really just because I like to use the this keyword, the end. I like it because it reminds me that this is an instance variable and because then it's nice and symmetric, like I'm always using this. So technically I only need to use this here, but I kind of like to use it anyways. And so I recommend you use it as well. Okay, so that's this keyword. So two constructors, they differ in terms of their formal parameters. Their only purpose in life is to give an initial value to every single instance variable. And you can use the this keyword to disambiguate between two variables that have the same name. And then I kind of like to use it even outside of that just because I like it, the end. Okay, so those are the constructors. Scrolling down, we see that basically the rest of the code in this class are just more methods. Okay, so I have a lot more methods in this class. Okay, so of all these methods, we can classify them into one of two types. There are accessor methods, which read and then return the value of an instance variable. And then there are mutator methods, which actually change or update the value stored in an instance variable. Okay, an example of a mutator method is my role method. So here's my role method, public int role. You'll notice that there's no static in any of these methods. Inside the role method, I call next int, and I pass in the number of sides of the die, and then I add 1 to that. So that's going to give me a number between 1 and the number of sides of my die. And I called that new value. Okay, so I've generated a new face value, and then I take that new value and I store it in my instance variable. So role is a mutator method because it's changing or updating the value of my instance variables. Then I go ahead and I return that back. So that's why the return type is it. Another mutator method is set face value. So public void set face value. It takes in a new value for the die. Notice I am checking. I'm making sure that the new value is greater than or equal to 1 and it's less than or equal to the number of sides. And that's because you should never, ever, 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 ever trust that the person using your code is going to pass in a valid input. Okay, so anyone could call this method and give me -1,000,000, 43, -2, right? They could pass in any integer, anything between -2 billion and 2 billion. And so it's really important to check and make sure that the input is valid. Now, assuming that this is true, so the new value is a valid integer between 1 and the number of sides, then I'm taking the new value and I store it in the instance variable. Okay, so again, set face value is a mutator method. Contrast that with get face value. Get face value simply returns back the value in an instance variable. Okay, so this is an example of an accessor method. Okay, it's just accessing or reading or basically just returning back the value. Again, you'll notice that in each of these methods, there's no static keyword. Okay, the last two methods in this class are very special methods. Just like every class you write should have constructors, so too every class you write will have a toString method and an equals method. So we're going to go through and just talk about what are these methods and how do you write them. Okay, so the first is the toString method, public string toString. The purpose of this method is to return a string that summarizes the state of the object. In this case, I've created a string here using the concatenation operator, and the string will tell you what the current face value is, and it will tell you what the number of sides is. I like to create strings that are kind of like in brackets, and it's like a comma delimited list, but the format really is up to you. Okay, so whatever format you come up with, it should be concise and informative and easy to read. So at its simplest, a toString method just takes each of the instance variables and it just appends them into a string, and it returns the string back. Notice that the toString method does not print anything. There is no system.out.print inside a toString method. None. We do not print. We are simply creating a string and we're returning that string back. Now, what's the purpose of a toString method? Usually the purpose is kind of for debugging reasons. So oftentimes when we write a class like the die class, we will have another class, usually called die controller or die tester, whatever, that has a main method, and inside the main method we'll create various die objects, we'll roll them, we'll print them, so on and so forth. You can call the toString method so that you can inspect the value of your instance variables and just make sure that you don't have any logical errors going on. So the toString method is just really nice to kind of peek inside an object and just inspect all of your instance variables, make sure everything looks kosher and I don't have a logical error. Okay, so that's basically the purpose of the toString. It just lets you peek inside and look at each of your instance variables. Last but not least is the equals method. The equals method takes as input another object, and you'll see that here. So I'm taking as an input another die object. Okay, so we have two die objects. We have this die object, and then we have the other die object that's being passed in. And the purpose of the equals method is to test if this object and that other object are equal to each other. And when I say equal to each other, it really just depends upon kind of the code you're writing. For a die class, I think for two die to be equal, they should have the same number of sides and the same face value. For a playing card to be equal, they should have the same suit and the same face value, right? We kind of already talked about this in the previous lecture. So if we look inside the equals method, what I'm doing is I'm saying, does this face value equal the other face value? Notice the face values are integers, so I just need to use the equals equals. So does this face value equal the face value of the other die? And does this die's number of sides equal the other die's number of sides? And if both of those things are true, then I'll return true. Otherwise, I'll return false. Okay, so the equals method, basically it will take in another object, and inside you'll check if these two objects are equal, and what it means to be equals changes depending upon the application. Okay. Okay, that's basically it. So this is our new type of Java class. It encapsulates some functionality. It doesn't have a main method because we're not meant to execute it. Instead, we use it inside of another class. And as our picture showed, inside there's really only two things. There's data, which is stored in variables. Sorry, my baby's screaming. And then there's just a bunch of methods. Okay, and we've got some constructor methods, and then we've got some basically other methods, accessor methods, mutator methods, of which two of these methods are kind of special, the toString and the equals. Okay, the last thing I want to talk about are new Javadoc tags. So you may have noticed going along that we have two new Javadoc tags, @param and @return. You must provide these for every single method. Even constructors require Javadoc tags. So the @param tag is used for the inputs to the method. So for example, in my set face value method, it takes in one input. So I have one @param tag. If it was to take in two inputs, I would have two @param tags. So each input needs its own @param tag. The format is you'd say @param, then you give the parameter name or the variable name, and then you write a description. So here I said @param. The name of the variable is new value, and then I'm writing a description. This is the new face value of the die. The second type of tag is the @return. Anytime you return a value from a method, you need to have an @return tag. So for this method get face value, I'm saying @return. Notice there's no variable name because we don't return variables from methods. We return values from methods. So there's no variable name. You just say @return, and then again, you give a description of what is the value you're returning. So here I'm returning the current face value. Here in the toString method, I'm returning a string representation of the state of the die. In the equals method, it has both. So it has an @param tag, the name of the variable is other, and it's the die that we're comparing against. It also has an @returns tag, right? And this returns true if this die and the other die are equal, and it returns false otherwise. Oops. Okay, what's the purpose of these Javadoc tags? I can now kind of reveal that to you. Every Javadoc comment that you write, when you toggle to documentation, there's a program that scans your code, pulls out all of the Javadoc comments, and creates this web page for you. So that's where this web page came from. So all of this text here comes from my Javadoc tags. When I click on a method, right, you'll see that all of this text, this is what I wrote. I wrote all of these sentences here. So once you write your Javadoc tags, then you can create your documentation. And then anyone who wants to use your class uses the documentation so they know, how do I create a die object? And then once I have one, what are the methods that I can call? Okay, so that's the purpose of the documentation. Okay, that is that. I think for my overview, I'm just going to look at the main page here. Okay, so in today's lecture, we went through the die class. We saw inside that there's really 5 things, I guess. There's instance variables. You should understand the syntax of writing an instance variable. You should also understand what it means when I say that instance variables store the state of the object. Then we have constructors. You should definitely understand the syntax of a constructor, but also what's the purpose of the constructor. Then we have various methods. Some of these methods are mutator methods, some are accessor methods, and you should understand the difference between the two. Then we have 2 very specific methods, the toString and the equals. Again, you should understand what the syntax is for both and also what the purpose is. So the toString returns a string representation, equals checks if this object is equal to another object. Last but not least, we have 2 Javadoc tags, and you should understand what they are and how to use them and when to use them. Okay, the in-class problems ask you now to kind of, I guess the in-class problems for this lecture ask questions about the die class, but for the next few class periods, we're actually going to take a break from lectures because we're just going to stop and you're going to be writing a lot of classes on your own. So you're going to get a lot of practice to write your own classes. Once you've written your class, you'll then write another class that uses that. And it's that other class that will have a main method. Okay, so that's kind of a look to the future. Okay, I think with that, we are all done.